Hello there. So today we've got this blue hand painted SMC Oscar 2. So the Oscar 2 is the CBM272. SMC were a Yaesu amateur radio dealer, and I think their headquarters was Eckington in Derbyshire. So they did the Oscar 1, which we did the other day, and I haven't got around to putting on eBay yet, which is the Cybernet set. This is nothing like as good a set, but this had a general purpose phase lock loop, which means that it's alterable easily to go on things like 10 metres. And they actually supplied this as a 10 metre set. In fact, one of the ones we converted back to a CB was an SMC supplied as 10 metres radio. And this particular radio has been kindly donated by one of our viewers, and thank you for that. And the plan is he sends this kind of stuff in so we can raise funds, because as most of you will know, I'm the sole owner to the GB3GR amateur radio repeater, which is on 70 centimetres, which lives out at Cold Harbour, which is 7.5 miles from here and just outside Grantham on about the only hill in Lincolnshire. And I pay commercial site rental and electricity and so on for that equipment, which of course I provided as well. So people donating things for two reasons, and one is to raise funds for the repeater, which I provide that service for free. I'm not going around with the begging bowl all the time. I do send a round robin email to our radio club saying that donations will be welcome, probably a couple of times a year, but and people do kindly send some dosh in. But things like this can raise some funds. But of course, I get the radio for free. I do the service work, which I've got to charge myself for. Can you understand that? So if I spend £35 on this and we start the bidding at £35 and we only get £35, well, it's not raised any funds at all, has it? So I've got to be careful not to overspend. So he tells me that this has had alterations done, and I'll need to look at the wiring of how it should be done, especially around the channel selector, etc. Now, it's a bit like the TV thing from the 70s Blue Peter. Here's one I prepared earlier. Here's a JWRM2, which of course is an identical radio with the same innards. So, and they do have very good transmitted audio, but that's about all I can say positive. There's a different version which is the which uses the standard LC7137, which is the York JCB 869, and also the Murphy DS602. So it's a variation of this chassis, and all these can suffer from transmitted audio hum. This particular one will need a socket putting on the back. There we go. I've run out of Uniden power leads, so it's going to be the crocodile clip job for this. I must get some from the wholesaler. This has been provided by the viewer with a business radio microphone, which I'm presuming is the good mics, but I'm presuming these went on a lot of Pi things, but I'm just presuming it's wired right. And I'm not going to power it up because he says it needs some wiring, and I believe him. So there we are. So we'll try and find a screwdriver that fits. So this will be ending up on eBay, and say the funds will go towards the ongoing costs of running GB3GR. So it's not like we've got a repeater group. I solely fund it. But the donations are always welcome. Oh, that saved me a job, didn't it? I waited for the printer to... It seems to be in some kind of fault status. So, I mean, it looks in good condition, but we've got all the wiring like a like what you'd expect. One of the reasons that synthesizer chips aren't in sockets is it can cause shenanigans, so it's not ideal. Does that say on it? Ranger. MC145106. So there are a lot of a faff to tune, because you've got to tune the 10.24, then tune the transmit, and then tune the receive, because you've got these different mixer crystals to achieve the frequencies. I'll just leave the printer creak. But we've done, I did a long range test, had Mark G7NDJ go 35 miles away in one of the cars with a full quarter wave, and sent him off with half a dozen, no more than that, 8 or 9 different sets, and I didn't know which ones he'd picked, and I didn't know which ones he was using. He just put a sticker on them all saying set number 1, set number 2, and of course when he came back with a box of sets, we then knew what they were. And this, I think it was the JWR version, came out the top of transmitted audio. So there you go. You know, it's some of the cheaper sets can be fantastic. While we're talking about these, the same inners are found in the ICOM ICB 1050, and it's important that people realise, and I've said this so many times before, the ICOM ICB 1050 has nothing to do whatsoever with the communications company ICOM. It could just as well say Calvin Klein on the front or Gucci. It's one of these. It's just somebody stole the name because he thought that might sell their cheaper end radios. Recommended price on these was $49.99, and you often found them at $19.99 because they got cleared quite rapidly. So we're going to have to use the crocodile clips, which we enjoy doing. Are we going to... I think we'll look inside this one and hopefully sort it out a little bit. That's also got no lids on it. Does that tell us something? So, as you can see, the wiring from the channel selector switch, I'll just unplug the mic for now, should go down like that. And it is indeed an MC145106, but it's normally branded Motorola and not Ranger. Is that some kind of fakery? Right, so the pink one goes exactly like it shows. The brown one is the first one. Yeah. What should we have? Brown and orange are transposed. Do these follow the resistor colour code? So let's have a look. 1 is brown, 2 is red, 3 is orange, 4 is yellow, 5 is green, and then you'd expect 6 to be blue and 7 to be violet. So it does follow the resistor colour code. If this set's right, so we don't even need to look twice at this. So 1, 2, 3, 4, 5, 6. So the end one's right and the red one's right. So the rest can come out. Now these printed circuits are pretty weak, so I hope we don't end up mashing it all up. Right, I'll put the camera to pause and I'll do that wiring, and then we'll start setting it up from scratch together. Right, so that's done that. These wires, some of these go to the high-low power switch, which has been repurposed for something else. Is it repeater shift? Whatever they did. What a faff. So put that on one side for a moment. And I now feel able to power this up, so you can see there's none of those extensions, and it's all wired straight in as it should be. So if high-low power switch hasn't been bypassed, then it's not going to have transmit. But we're a long way from that. As you can see, these cores are right about out of the end, whereas you can see on the normal set they're not. Most of these conversions never worked. People failed to do them or broke the sets in doing them. So I've never seen one that worked. Right, we'll plug that mic back in. At this stage, I'll use the instrument speaker. We'll have to use the crocodile clips. I'll make sure I've got some leads by the time I plug this. If I can fix it. There we go. Right, we'll power it up. So pop it. I was going to pop it to try. I'm not going to be able to show this up much because it's going to come unplugged. So what we're going to do is I'm going to put 2779125 on the signal generator for channel 20. We've got whacking signal on. I've got full amount. Transmit. Let's go to the 3-watt scale. I'm not expecting it to transmit, and it doesn't transmit. Now, where have I put my walkie-talkie? Something which I've just can do without any further ado is to put these coils to a position that they are in this normal set. So at least we've got a fighting chance without getting fancy instruments out. Now these are polythene cord, so what we don't want to do is to put the soldering iron on the core, on the kind of plastic surround. So just warm that up a bit and hope we can get that. Yeah. So when I look at this one, it's going to be just under the flush. Just do that again. Out there. Do the same with this one. Can't even see where that core is. And then we've got the one here. Well, look at that. We've got lock. So, what that proves, change channel, is we've got the phase lock loop working. It's locked, and we've got receive, which is working well. That's 10 microvolts, which you might think's lousy, but considering. So I mean, we've got a receive coil there. I can put that down because clearly it needs to. Just as this is just a rough initial. So I'll just put the cyanide meter on. I'll tell you. So that brings us to 1.9 microvolts. So we've got another one there. I think that's got a bit of damage to it. If that's the case, I'll take it out and put it in the other way around. That's the first one which is damaged, but the other side isn't damaged, so pop it in the other way around. That doesn't look promising. Oh, it does move. Well, can't remember where that one is in the circuit. We'll go through the setup properly in a moment. So right now we're at 0.55 microvolts, so it's fine. It's kind of sensitivity you expect. So that's chuffed me no end. So what I now need is my walkie-talkie, and we'll monitor where we are with transmit. Just check there isn't transmit still. Not that I can see. I'll pause the video. Right, so we've got the walkie-talkie here. Let's see whether it's actually transmitting. And the answer is no. Right, so what I now need to do is find the notes for this kind of radio. Now, I was doing a DNT, which I haven't shown you because I never got anywhere with it. So I did get some notes out. Failing that, I'll have to print them off again. Alright, well, first thing we're going to do with the more complicated setup is make sure the 10.24 is correctly set. So that is 10.24 on this radio, and we just need to, it's pin 3 and 4, to make a rudimentary probe out of a screwdriver. I'm sure it's earth chassis on these. So if we poke that to pin 3 and to pin 4, it's whether we can get it anywhere near. 10.2375. Check it on the other pin. Two, 377 is probably as high as we're going to get it. See whether the rest of it will set up without changing that crystal. Okay, so we know did I do that coil? I did. I can't remember. Let's put the walkie, make sure the walkie-talkie right. It is. There we have it, we've got transmit. And it's full 4 watts just like that. Make sure it's in the centre of the range. Go to the frequency counter and see whether we can get it on frequency. I've got it slightly high at that. I'm going to have to be fiddling about, aren't I? We're spot on the 4 watts there. Should be showing you the right meter, of course. There's the 4 watts. So we did the front end, but I'm going to do it. Tell you what, we'll do the detector. Let's put the signal generator on. In fact, I think we ought to get it on frequency first, don't you? Yes, Mr. Tango, I think you should. So we use the secondary signal generator to give us 10.695. Take the tone off. Turn the volume up. Dangle the wire somewhere near and adjust receive. So I'm going to play compromise time now. So going to go into transmit. Let's put that frequency counter back on. Let's see if we can just drop the frequency slightly with the 10.24. It doesn't matter if it's slightly high, but if we can just get it leave it there, and then adjust the receive here, so we're spot on, and then go back to transmit. So 79131. Switch the signal generator off. I can't do before and after, of course. We're going to have to do high-low power, come back to that. Let's check it works on channel 40 and 1. So go back to the main meter, channel 1 is 4.05 watts. And channel 40 isn't transmitting, that's VCO. That's 4 watts. You've got a lock detector. There isn't a normal method like we'd use on the Cybernet, but there is a lock detector we could monitor, but we may as well just monitor 1 and 40. It's the same effect. There's 40, there's 1. there's 40, there's 1, that's well in lock. Back to channel 20. Just for the laugh, we'll see what the deviation is. Wallow. We've got no transmitted audio. Why would that be? Let's listen on our walkie-talkie. Testing 1 2, testing 1 2. Okay. That could be the mic. Let's just have a poke around. I'll just put the walkie-talkie back on. And we'll just go on the mic socket and see whether we've got audio. Possibly not. What wire should be on there? So we should have black, brown and orange. We have. So it's probably had some strange modification we just can't have a look into. Gonna knock the power off. That's always the trouble when you do it like this. Right, we're going to do the receive. So we know it's now on frequency. So I'll put the frequency, the signal generator away. We know that the 10.24 is something like 10.237, so that does affect the IF, but I don't really think it's going to matter in reality. Let's just go through a few of these tick boxes. Meter lamp's working. Doesn't have PA. Sockets are working. The potentiometers are working. On transmit, it should be in the centre of the red zone. So we just need to adjust the preset, and the preset is 304 power meter, which is that one. I can't really lift it up and show you very easily, or I'm going to end up. That's now in the centre of the red zone. And so we've got the signal meter. 100 microvolts is on right now, but I just want to make sure we've got the IF right before calibrating that. And it's this one. Let's make sure we're on the oscilloscope. Camera 3. That was spot on. It shouldn't have altered. This has nothing to do with any conversion, so that's good. We'll just check we've got the IF somewhere like right. Turn the squelch down. Put about 12 microvolts, 12 dB on. T104 is a capacitor. Not seen that modification before. Okay. point is, does it work, you know? So just make sure we've got the cyanide as good as we're going to get it. So as long as we've got it under point, somewhere under like 0.5, which is what it's doing, it should be alright. Just drop the signal a bit further, put it to about 6, see whether we can get anything else. No, I got that pretty well on my rough. No, my rough setup wasn't rough at all. I want to keep that in position. Well, receive meter. Oh, what we're getting, what we're doing. It's 0.55 for 12 dB. .5 and actually a very reasonable 0.95 microvolts. Squelch, is it adjustable on these? Well, it's not coming into 100 microvolts, which is what I'd like. Let's see when does it ever come in? No, it doesn't. Never opens, and on minimum it's just not quite, it's 0.52. See whether we can improve on that. Let's look at the notes for the squelch, if it has it. So we've got power meter, signal meter, deviation, low power, which we've yet to re-implement. Is this extra preset squelch? Yeah, it is. Shouldn't have that, it's been added in. So we'll try again with our 100 microvolts. Put the attenuator on the inset picture. I can't even see the inset picture. We've been going all the way with no picture in picture. Yes, we have. Right. Let's see. 3, 10, 30, 100. So this setting opens at 450 microvolts. Well, that's the most sensitive we can get, so that's better. And at minimum squelch, what have we now got? It's got to be acceptable. It's not acceptable, you see at the other end. that gives us 0.49, but I think we're going to have lost the top end again. Put it to full. No, never opens. Right. So if we actually talk on our walkie-talkie, a few inches away, does it open? Testing 1, 2. No, it doesn't. I knew there was a lousy squelch involved somewhere. So we're looking at S9 on the signal meter, which is there. It's being a bit generous. We'll just back that off a bit. There we go. So there's two things to sort out. Why is there no deviation? And we've got all this to sort out to restore high-low power. Just a quick look at this transmitted audio. Just wondering if we've got anything on the deviation control. There isn't. Yes, I can see we're going to have to look into what's happened there. To be honest, there's not many bad things happened underneath, or it's been well cleaned off. So on our high-low power switch, we've currently got a green wire, a brown wire, and nothing. On our normal set, we have a red, orange, and yellow. That's the word. So, well, where that goes, we have no connection. So that can come off. I'll make sure it sets off. We'll unsolder that wire. It's not supposed to go anywhere. Whoops! Bet that came through on the mics. So it gives us an orange and a red wire. The red wire goes down here, and the red wire on this set has been chopped off. So let's unsolder. Might be able to do this without taking the front off. Usually you can't on more normal sets. So what we're going to have to do is to add in a red. We are going to have to take the front off. So that's easy enough. We can see where that goes. This centre wire. That centre wire is the red. We should have orange to the bottom. And I suspect it's that orange that goes into the PA. The orange that now goes straight to the volume control. not going to unsolder it, I'm going to cut it off. So happy it's that wire. Yeah, it's definitely that one. So it should go, I expect, to the high position. It's where we start spending a lot of time. And you can't take the front off on these because you've got to unsolder the mic socket. So hopefully we can dislodge it to one side. So I'm going to end up with an SMC Oscar 1 and an SMC Oscar 2 on eBay. To be honest, that's all I need to do, so I'm not mashing up the solder. Well, to be honest, we need to get the yellow one in first, which we haven't explored, and the yellow one simply goes down to that preset, which is exactly what we know it is, which is low power. What's in its place then? What somebody's put in there? They've got orange. No, they haven't put anything in there. I don't expect that orange wire is long enough. Do you know what it is? That's probably the orange wire that came out. So if we look at where that goes, it's going to be that hole there. Well, it's going to be a hole when I've dealt with it. Just like that. I'll just make sure we can actually get the wire in. I'm trying not to cut anything off. Yeah, that end will go in easily. Right, so that's our low one reinstated. Want a bit of a I'll cut this one off rather than try and unsolder it. Just nick a bit of red wire out of some scrap set. And have we got time to do the orange wire? There we go. So we'll just try it, and I'll go and do something else. Let's put that front on a bit more. And then we've only got deviation to sort out. Power supply on. Okay, so we're in the high position. Let's switch to the main meter. We should have 4 watts, and we have got 4 watts. Switch to the low position, and that presets at whatever it once was. Do you know, it's at 300 milliwatts. Now it's at 400 milliwatts. That's wonderful. Just got transmitted audio. Wallow to worry about. So there we go. We'll leave it for now. We'll come back to that in due course. Okay, I'm going through this audio circuit. We've got it the far side. So we've got a varicap diode there, and we've got the deviation control here. Resistor 56k there, resistor 312. So I can get myself a buzz all the way through there. We can't this side of the deviation control. So we've got 2 transistors. So our input goes in from pin 1, capacitor, NPN transistor. We've got an electrolytic capacitor that could have failed. If that was open circuit, we'd have no transmitted audio, but I'd expect to be able to get a buzz by touching round here, but I can't. And I think I've just spotted a short circuit. So let's just zoom in. Somebody's changed something. Let's look on our other set what they've changed. I think that's a short circuit. You've got a capacitor across there, which we haven't got on this one. So what's the other side? The other side looks like we've got, could be an electrolytic capacitor. I'll tell you what, I'm going to let's zoom in and I'll show you what I'm thinking about. Right. So I'm looking around transistor 1, transistor 2, and I can see a short between there and there. So I'm going to switch the radio off, and we'll go and we'll get the solder slurper on that. I'm just going to do potential dry joint there, potential dry joint there, and that one which we're dealing with, potential dry joint there. I'm going to go over this, of course, with isopropyl alcohol, but I now can't see a short. Testing 1, 2, and we've got audio. Wow. Well done, Mr. 21. I'll set the deviation on this test set, and then we'll check it on the other one. Wallow. other test set isn't switched on. I've also looked at while I was printing these off, one's from the JWR and one's from the ICOM, and of course they're identical. Oh, I'm not in the right... there we are. The two circuit diagrams, they are identical. I looked at the instruction book and it says sensitivity better than 1 microvolt at 10 dB. And what have we got? I've looked at the wrong sheet. That was yesterday's. We have got 0.55. Whilst the other test set warms up, we'll just check our current consumption. It's 1.2 amps. .400 milliwatts. That's done. That's done. That's done. In lock. And we haven't got it before. Very shortly we'll have an after. I'll have to come back in 15 minutes or so, and when that machine's warmed up. Okay, well it's 3.2. Of course that's not because somebody set it wrong, it's because it's had to be fiddled with to fault find. No, it's not. Well, might works. So I think we'll have a look at this JWR in about a week. See whether that can be resurrected. I'll just talk to myself. Always doing that. Testing 1 2, testing 1 2. So we're using a standard business radio mic. You know, if it sounds awful, well, we can always swap it for something else. But they are different wiring to most other types of microphone. So we are done. So I've popped the soldering iron back on, and that acts back to the speaker wires. It's a bit neater without all those joins. I think that's worked out well. So apart from the reference oscillator, 10.24 reference oscillator being very slightly low, once again, you know, the transmitter and the receiver set separately on these radios. That theoretically affects the IF of the receiver, but I don't think it's going to matter. Right, so lid. It's the blue one. I nearly put the black one on off the JWR. So potentially you can end up with hum on transmit. Oh, there was one other thing I wanted to look at. I've got spurious emission alarm coming up on my test set. Now, is it true? I'm going to put it on the spectrum analyzer. So it puts up a warning. I don't know whether I can show you this. And then move it across. we've got a triangle with an exclamation mark, which is either overpower, and we're only on 400 milliwatts. When I key up, we've got the, so in low power we're not getting it. Go to 30 watt scale, but in high power we're getting the alarm. So just pop the spectrum analyzer on. Just got a naked old bit of power lead we just use as a sniffer. See if we can switch to the spectrum analyzer screen. Can we move the camera? Oh dear, we've got glare on that. Let's see what happens. Oh, we're in high power. Let's put 27 megs up. Frequency 27,79125 megs. What we got there? I'm just going to see whether we've got one of these the wrong side. Well, that looks more like it should do. We're now only drawing 1 amp to deliver 4 watts. So I think we're there. So it's now 1.03, I think it was. Just check. 1.0007, just like James Bond. Right. Anyway, we'll see how it works around Scratchy Corner. We'll soon find out. So I wonder when this last worked as a CB radio, and I wonder when it last worked at all. I don't think it will have worked since it was messed with. Anyway, it can stay hand painted blue. Need to go with isopropyl alcohol. So I'll tell you what, we'll just put the aerial in. try and get it to stay connected whilst that'll be a bit of an art. Nah. One out of Roger. Again, it's about 5:45. 19 a Roger. Can't be bad. Right, there we are. I'll just do the isopropyl alcohol and we'll be on doing the on-the-air test pretty shortly after that. So thank you for watching. And now resurrected X-modified SMC CBM272, the Oscar 2 from 1982.